Welcome back to our third episode in a series where we look at having a CAD model, looking at it within our CAD program, looking at the top front right views. That was the first episode. Second episode, we then looked at the dimensions of specific parts. And in this third episode, this is the last step of the process. And maybe to take an even bigger step back, we're assuming that we are coming up with an idea where we're going to have a machine, specifically a CNC, computer numeric controlled machine, make the thing for us. Now, there are other episodes that talk a bit more about this, but even something like a normal inkjet or laser printer, that's a type of CNC because you type out the words and the machine does it for you. Likewise with 3D printing and laser cutting and other sorts of CNC machines, you have a design. Okay, now if you haven't seen this 4 steps before, you have to come up with the idea and be inspired. This has nothing to do with computers. You design. So in this series, we used Tinkercad, and we've had a whole series on Onshape. There are other CAD tools such as Rhino, SketchUp, Fusion 360. Whatever you use, you make a digital representation of it. Then it needs to get translated. In the case of 3D printing, it's going to slice, and then the printer itself is going to make it. And so this arrow is sort of where we're at. We're about to either slice it ourselves or get a teacher to help us out, but we want to have a reality or sanity check. And this just means you've been designing this thing all along on your computer. You're zooming in, zooming out, and it's easy just to get disoriented. You don't know what the scale is. And these were the dimensions that we pulled off from the previous episodes. So I'm going to show you what I recommend students to do before they show the design to the teacher. You have some sort of model in your CAD program, some sort of design, some sort of thing. And the main question we are asking is the design you have the design you want? And at first glance, this might seem like a question of, well, why wouldn't it be the thing that I want? Well, you just want to check. It's that sort of measure twice and cut once. The other thing I want to illustrate, you've seen the view cube before. Now, if there are any experienced engineers out there, I just sort of remembered this sequence from memory. It may be flipped somewhere, but you imagine a box that's unfolded and you sort of have the different views. So you know the top and the bottom, that's going to be opposite sides, left, right, front, back. And what we're saying is our design, all right, we want to know what size box does it fit in. And off to the side, I have my Tinkercad file. In the previous episode, we showed you how to get those dimensions. Hopefully in whatever CAD file you're using, you can also pull off those dimensions. And now we just want to see in real life what that looks like. And whether you're working in inches or millimeters, it takes a while to build that intuition. And even if you have that intuition of what this actually, the dimensions are in real life, it's still a good exercise to have. So we got the dimensions. This is sort of what we're aiming for. So I've got my trusty calipers here. There's 3 episodes on calipers, so I'm not going to walk through how to use it. The other thing I want to mention is when you're measuring out to decimal places, that's 1,000. So if we look at the calipers here, we have the ones, tenths, hundredths, thousandths, 10,000. So you see, even just a few thousandths, that's really imperceptible. And you should just do this yourself so that you can see for yourself. So just for making it a little easier, I'm just going to round this one to 2. I don't know, let's round it to the tenths. Because again, we're just getting a general sense of how big our box is. Okay, I'm not sure if this is going to fit on the page, but let's give it a try. So we've got our first, the largest, 2.7, so open that up. Okay. Now, if you want to use an actual straight edge, you can. Here, I'm just going to freehand everything, and if you haven't seen the episodes on drawing and drawing lines without a ruler, I encourage you to watch that. So 2.7, close enough. I lock it, just out of good habit. Oh, this is pretty loose. Okay, there you go. And we're just going to mark that off. Maybe I'll go here. Again, there's a whole sort of style. What I mean by style is if you've ever done a research paper, you have to format it like MLA or Chicago, whatever. There's also sort of a style for drawing, so forgive me if I'm not getting exactly the right rules. Okay, so here we go. All right, a nice, so that's 2.7. And then let's measure, sure, let's do the 1.8. So we'll loosen it All right, make sure I'm still zeroed. Yep, 1.8. Good enough, okay? Engineering is about good enough. Sometimes you really do need to be exact. You know, you have a press fit, you have a bearing. You want to make sure things are exact. Other times, it's good enough. All right, so 1.8. All right, might not be perfectly 90 degrees. Here we go. All right, so let's see. I'll practice my freehand straight lines. All right, and you know, we're just sort of eyeballing here. Okay, so you have that. Let's go over to this dimension. Why don't we make this, we'll just give it a little space here. We'll make that, let's mark what I just did. That's 2.7, that's 1.8. So I want my, if this 1.8 is going to be shared, let's make this 2. All right, like that. So of course 2 is kind of close to 1.8, so maybe at this level of fidelity you can't really tell the difference, but no, you can see it's not quite square. Okay, so we did 2 that way. And now let's just mark this 1.8, so you kind of want all combinations. So which combination do we not have? We don't have the 2.7 and the 2. So if you imagine this folding up, that would be a shared edge with here. I know I'm drawing over my notes here, but that's okay. Got that 2 inches here. If you were actually doing this, then it would be a lot cleaner. So again, if there was no gap here, you know that this would share an edge and that would be the same distance. Okay. Right here. Okay. So now that you have this, you know that your print is going to be this big or this small. The last piece in our, I guess, reality sanity check, let's say your smallest feature was, I don't know, 0.07. I had mentioned 0.05, roughly the thickness of a dime. That's sort of a good rule of thumb. But whatever that thinnest feature is, all right, whether it needs to be strong enough or whether you're looking for a certain visual, you want to use the calipers. Now you have the dimension dialed in and make sure that that is what you want. Okay, so I think that's it. That about covers it. So again, in conclusion, you have come up with a design. You're trying to go to the next step to get it prepped, but you want to have a reality and sanity check for it. And certainly if you're in a school context, the teacher is going to ask you, show me your work. So that's why I've created these 3 videos so that you can learn about this process, apply it to your design, whatever CAD program that you're using, and then show that you have seen it. And now, even if you have answered the question, yes, the design that I have is the design that I want, the teacher may ask, hey, is there a way to reduce material? Is there a way to scale it down? But at least you've done your part. Thanks for listening, and we'll see you next time.